Hi guys, welcome to Nat 5 and 5. We're going to be looking at sketching quadratics today. This video assumes that you've watched the previous videos. We're going to be really looking at the y-intercept today and then bringing everything else together and sketching them fully. Right, so at the top left hand corner, if we consider y equals 0, so we have talked about this in all the other previous videos, but I'm just going to make it really clear what's happening. If I, remember this is your x value and this side and this is your y value, I'm going to consider y equals 0. So the whole way down, I want to consider what the coordinates look like when y is equal to 0. I'm going to change my x value. So if the first one was x is equal to -3, we would plot that. So along your x-axis you're going to -3 and you're not going up or down in the y direction because y is 0. So here I'm putting this little cross as my coordinate. Next one, if I consider x is -2 and y is 0, this is where my coordinate would be. Next one is -1, 0, this is where my coordinate would be. So 0, 0, this is where my coordinate would be. If it's 1, 0, here's my coordinate. And if it's 2, 0, here's my coordinate here. Now you should be able to see when y continues to be 0, it doesn't matter what the x value is, doesn't matter whatever x value I choose, if y is always 0, it will always cut the x-axis. So you can see here I wrote at the bottom, an x-intercept is a point on the graph where y is 0. So we'll say what x-intercept, or we can say cuts the x-axis. And again, in previous videos we've talked about this being known as the roots. So when you're asked to find the roots of something, you're finding where it cuts the x-axis. Okay, if this is something similar over the top, right, we're going to consider x is equal to 0 now. So again, this is your x, this is your y. If every time your coordinate for your x is 0, if you consider y being -3, so I'm going 0 along the x direction and then 3 down in the y direction. This is where the coordinate would be here. So -2, 0, -2 would be here. 0, -1 would be here. 0, 0 would be here. 0, 1 would be here. And 0, 2 would be here. You can see where I'm plotting them. And again, a y-intercept is a point on the graph where x is equal to 0. This is something we've not really looked at yet. It's a new thing. So if you substitute into a quadratic equation x is equal to 0, you're finding the y value out, and that is where it cuts the y-axis. So let's have a look at our next slide. So kind of similar setup to our previous video. I'm just going to take you through, we've got an extra column here, the second last column, the y-intercept when x is 0, so that's the new skill we're learning. So let's have a look at the first one. Right, we've got x squared plus 4x take away 5. Again, I'm going to look at this x squared so you know the shape is a parabola. It's a happy face, a happy shape. You're going to find the factors, you're going to factorise. I'm just going to do this quickly. I'm assuming now you know how to factorise, so it should be x and x. The only options are 5 and 1. To make a positive 4, it must be a positive 5 and -1. Okay, so we're on this part here, we're finding the roots now, or the x-intercept, and that happens when y is equal to 0. So you're going to replace this y here with 0. So we've got x, add 5, x minus 1, take away 1, equals 0. You're going to take each bracket separately. Right, we need to do 0. We've done this several times now in previous videos. If you wanted to go one step further and just write what that coordinate would be, it means it's -5, 0, and 1, 0. Okay? Now if I just write the original quadratic equation out, which is y equals x squared, add 4x, take away 5. And you're now considering the y-intercept when x is 0. So whenever you see an x is 0, which is here and here, you're going to replace it with 0. So it's really, I'll just do the long way so you can see, it's going to be 0 squared, add 4 multiplied by 0, take away 5. Now 0 squared is 0, 4 multiplied by 0 is 0, take away 5. So your final answer is negative 5. And you don't really have to do the long step there, I'm just showing you what's happening. You can substitute 0 almost in your head and you'll know that the y must be negative 5. Again, if you just wanted to write a coordinate for that, your x value is 0 and your y value is negative 5. Plot your graph now. So negative 5, 0, which is here. 1, 0, which is here. And 0, negative 5, which is here. And you know what shape it is. Back to your shape. This shape here. So you're just going to, oops, it's a pen. Want that shape there. Okay, and further videos will look at the axis of symmetry and the turning points of these. So let's go on to the next one. So again, x squared, so parabola, it's in this shape here. We're going to factorise it. So the x and x. So 6 and 1. Yep. X squared is 6. Yep. Okay, so I just double checking that. And then you're going to find the roots. So basically you're making y equal to 0. I'm just going to write at y equals 0. So x take away 6 equals 0, so x equals 6. X add 1 equals 0, so x equals negative 1. And again, if you want to just write that in terms of coordinate. Coordinates there. Next one, if you write it the original one, you're substituting x is equal to 0. I'll maybe write that actually. That x is equal to 0. So you're taking your original quadratic and you're replacing the y with 0. Work that through, that's negative 6. So your coordinate, remember your x is 0, so that's first, and your y is negative 6. Again, you know the shape. So we've got 6, 0, negative 1, 0, and 0, negative 6. We can put that there. Okay. Next one. So we've got, when we look at the x squared, it's a negative x squared, so the shape's going to look like this here. We're going to factorise it. The difference of two squares, it's going to be 3 add x and 3 take away x. You're going to find the roots. That happens at y equals 0. 3 add x. Just write this out equals 0. Right, okay, so 3 add x equals 0. So x must equal negative 3. 3 take away x equals 0. So x must equal 3. If you just write the coordinates, so it's negative 3, 0, and 3, 0. And similarly, you find the y-intercept, that happens at x equals 0. Write your original quadratic equation. substitute x is 0 in. 0 squared is just 0, so y must be 9. So you've got x is 0 and y is 9. So if I had to plot that, I've got -3, 0, 3, 0, and 0, 9. And remember what the shape looks like. It's going to be symmetrical because it's through 3 and -3. Okay? Next one, from x squared. Yep, there's a positive. So this is my shape. You'd recognise it's a difference of 2 squares again, so it's 2x add 5 and 2x take away 5. Find the roots. At y equals 0, taking each bracket separately, making them equal to 0. So take 5 away from both sides, divide by 2, just leave it in fraction form. Same with the other one. 2x equals 5, so x equals 5 over 2. The coordinates of that are -5 over 2, 0, and 5 over 2, 0. Remember when you're plotting that, like I'm keeping it in fraction form, but 5 over 2 is just 2.5, 2.5. The next one, the y-intercept that happens at x equals 0. Write your original quadratic equation. What's going to happen here? I think you can see the pattern happening. So 4 multiplied by 0 squared, and then 25 is taken away. Anything multiplied by 0 is just 0. So your y equals -25. Again, if you want to write a coordinate for that, your x was 0 and your y was -25. If I was to do a quick sketch of that, obviously these are not to scale because I'm going to -25, which is going to be furthest away I can. -5, 0, -5, sorry, 0, -25. And then we've got -5 over 2 and +5 over 2. You know what the shape looks like. You go down, up, and round. Okay guys, hope that was really helpful. You've got another page here, and this is going to be homework. So please make sure you copy down all these examples. And I'm going to flip to the next page now. It's a very similar setup from the examples I just did, and this is your homework. Okay, so good luck.